The common use of harmful and toxic batteries that lead to detrimental consequences for both humans and the environment was the inspiration for this project. In this project, I aimed to explore the potential of non-hazardous aqueous batteries as they are eco-friendly and easily disposable. By assembling them with the right materials and applying the right conditions to them, they have the potential to be more efficient and cheaper than the hazardous batteries that are often used in modern times. For my hypothesis, I believed that when non-hazardous aqueous batteries use the right chemicals and are exposed to higher levels of humidity, they will perform better and be more environmentally friendly than most standard batteries, as they use safer chemicals that are easier to dispose of and will produce more voltage with increasing size. This was later supported by my research results. In order to conduct this experiment, I filled 5 beakers with 200 milliliters of distilled water each and used them to make different mixtures containing 5 grams of sodium chloride, 5 and 11.56 grams of sodium acetate trihydrate, and 5 and 7.14 grams of sodium bicarbonate, respectively. I then attached copper and aluminum strips to a multimeter and used it to test the voltage of the batteries. Data was gathered when the humidity ranged between 66 to 70% and 94 to 100%, and each range had 5 measurements for each type of mixture. Using this data, I was able to make analyses and draw conclusions. For details, here is a list of the materials used in this experiment. I also included a schematic for the battery, and as you can see, I placed 1 copper electrode and 1 aluminum electrode on opposite sides in the electrolyte solution, and the digital multimeter, which was attached, was able to collect data on the voltage output. On this slide, while the exact values of the voltage outputs are shown on these charts, they are rather confusing due to the amount of values gathered. So instead, I will show a slide that contains all the graphs of the data gathered. As you can see, there are 2 sets of data, with one having the same mass for all 3 types of electrolytes, 5 grams, and the other having the same carrier concentration, which just means that there are the same amount of charged particles. The sodium acetate trihydrate, which is the orange bar, had the best performance out of the 3 types of electrolytes in all scenarios, and its voltage output was boosted even further when the humidity was around 94 to 100%. Something else you might have also noticed is that in all cases, the sodium chloride was kept at a mass of 5 grams. This is because it served as the standard of comparison, due to it forming a neutral solution and being one of the most common electrolytes available. 5 grams was chosen because less sodium chloride would result in a drastic decrease in performance, while more sodium chloride would result in a cloudier solution that didn't increase much in voltage output. By analyzing this data, I found that the 5 batteries have a significantly higher voltage output than the other batteries, especially when the humidity is around 97% or higher, and this difference may be due to sodium acetate trihydrate inherently having a higher potential and solubility than the other chemicals, and it may also be due to factors such as the pH of the water after the electrolytes dissolved in them, and the number of cations and anions in them. Finally, the data showed that humidity does seem to improve the performance of the batteries, as they had a significant increase in voltage output after the humidity range was raised from 66 to 70% to 94 to 100%. This could potentially be due to the increased conductivity from the water vapor that is present in the air, and seems promising for maximizing the potential of aqueous batteries. Findings from this experiment indicated that the sodium acetate trihydrate with distilled water mixture was easily the best electrolyte tested, especially in moisture levels over 97%. Its voltage output also increased along with the size of the battery, and it would cost less for the same voltage output as a typical 12-volt lead-acid battery. In conclusion, although aqueous batteries may not be as portable as modern batteries, they have environmental benefits and can produce significant amounts of energy with the correct approach and right humidity levels. Overall, they function better in larger units, and this study can be used to help develop the means for storing and utilizing them. Finally, here are my references. Thank you for viewing my project.